Have you ever wondered why the space between the stars is so unimaginably empty, and yet it is the very fabric that holds the entire cosmos together? When we look up at the night sky from a dark location, that hazy band of light stretching overhead is actually the combined glow of billions upon billions of distant stars in our own galaxy. For most of human history, we assumed that was everything. We thought our galaxy was the entire universe. We are used to density, to things being close together, to the world being full. But step outside our solar system and emptiness becomes the rule. This emptiness is hard to wrap your mind around. However, the truth about this vast emptiness is far more profound than simple nothingness. And it begins with a paradox that challenges our basic perception of reality. The universe is not a still, quiet stage where things simply happen. It is an active participant in the cosmic dance. It is expanding, and not just expanding, but accelerating in its expansion. This is not an exaggeration. This is not dramatic storytelling. This is the honest truth about a cosmic mystery that quietly exists in the darkness of space, connecting the largest structures we can observe to the smallest quantum particles. Before we dive deeper into this quiet journey through the infinite, I want to invite you to pause. Take a gentle breath. Feel the stillness of your own space. Hello, my friend. Welcome to our shared journey. I am Walter, the explorer, and I will be your gentle guide as we navigate the vast and ancient mysteries of the cosmos together. As we prepare to venture further into the deep silence of space, I want to share a small observation with you. I have noticed that 73% of the wonderful people who watch these cosmic journeys have not subscribed to our channel yet. If you find peace and wonder in these quiet stories, please consider subscribing. It helps our community bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Thank you for your continued support and curiosity. Now, let us return to the stars and to the deepest origins of the expanding void. To truly understand what the expansion of the universe is made of, we must look at both the unimaginably large and the incredibly small. In the strange world of quantum physics, the concept of a true, empty vacuum does not exist. Even in the deepest void between galaxies, quantum mechanical effects are constantly at work. Particle pairs are constantly popping into existence and then annihilating each other in a gentle, unending rhythm. This happens everywhere, all the time, a quiet symphony of creation and destruction that goes entirely unnoticed by our human senses. We live on a crowded planet, surrounded by billions of other people, sharing space with countless other living things. Yet, in the silent depths of space, this microscopic quantum dance is happening across distances so vast they beggar imagination. This microscopic quantum realm might seem entirely disconnected from the grand scale of the cosmos, but the universe builds things from the bottom up. It starts small and grows large through countless interactions over cosmic time. The expansion of space itself is driven by something scientists call dark energy, a mysterious force that makes up about 68% of the total energy in the universe, but whose nature we do not understand at all. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down. This made intuitive sense. Everything in the universe is pulling on everything else through gravity. You would expect all that gravitational attraction to act like a brake, gradually slowing the expansion that began with the Big Bang. However, the universe is generous with its marvels and surprises. In 1998, two independent teams of astronomers made a shocking discovery. They were measuring the expansion rate of the universe by observing distant supernovas, using them as standard candles to calculate cosmic distances. What they found was completely unexpected. The universe was not slowing down, it was speeding up. Distant galaxies were moving away from us faster than closer ones, and the rate of expansion was accelerating over time. This discovery was so unexpected that the astronomers initially thought they had made an error. But as more data came in from more supernovas and from other observations, the result held up. Something was pushing the universe apart, counteracting gravity, and causing space itself to expand at an ever increasing rate. Scientists named this mysterious force dark energy. Though the name tells us very little about what it actually is, we know that it acts as a kind of anti gravity, pushing space apart rather than pulling it together. We know that its effects become more important over time as the universe expands and ordinary matter becomes more spread out. It might be a property of empty space itself, something called the cosmological constant that Albert Einstein once proposed. It might be a new kind of energy field that pervades the universe, or it might be intimately tied to those quantum fluctuations, the particle pairs constantly popping into existence, providing a subtle but relentless pressure that forces the cosmos to stretch. What we do know is that dark energy is reshaping the future of the cosmos. Let that sink in for a moment. The space that separates the stars, the immense distances that take light millions of years to cross, is not just a passive container. It is an active, stretching fabric. Light travels at about 6 trillion miles per year. Even at that incomprehensible speed, the light we see from distant galaxies has been traveling through the void of space for more than 1 billion years just to reach our telescopes. When that light began its journey toward us, life on Earth was still mostly single-celled organisms. Every major event in human history, from the first civilizations to the invention of the telescope itself, happened while that ancient light was still crossing the emptiness between galaxies. And during all that time, the very space it was traveling through was expanding, pushed outward by the mysterious dark energy. When you look up at the night sky, you might feel small. You might feel insignificant in the face of such vastness. But the existence of this expanding cosmic tapestry actually tells us something hopeful about our situation. Consider that we can know about this expansion at all. Human beings living on a small rocky planet, orbiting an ordinary star in an unremarkable part of an average spiral galaxy, have somehow developed the ability to understand objects and forces so far away that their light left before complex life existed on Earth. This ability to understand is not nothing in a universe of mindless matter and energy, of particles bouncing around according to physical laws. Somehow here on Earth, consciousness has emerged, minds that can wonder, question, investigate, and learn. Whatever else we are the part of the universe that has woken up and started asking questions about itself. The atoms in your body were forged in stars. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood, all of these elements were created in the nuclear furnaces at the cores of stars that lived and died before our sun was born. We are made of star stuff. The same atoms that shine in distant galaxies shine in our eyes. We are not separate from the universe. We are part of it. We are the universe observing itself from within. And as we observe, we realize that the universe operates on time scales that dwarf individual lives, individual civilizations, even individual planets. As space expands faster and faster, distant objects recede from us at ever increasing speeds. There is a limit to how fast light can travel, but there is no limit to how far space itself can expand. Eventually, objects will be carried away from us by the expansion of space faster than their light can travel toward us. When that happens, they will vanish behind a cosmic horizon, forever beyond our reach. But that day is far in the future. Right now, we exist in this brief moment of cosmic history when stars still shine and galaxies still glow. The era of stars and galaxies is just a passing phase, a brief flowering of complexity between the chaos of the early universe and the cold emptiness of the far future. We are lucky enough to exist during this flowering. Our curiosity is the cosmos being curious about itself. When we ponder the nature of dark energy and the quantum particles that might fuel it, we are engaging in a tradition of inquiry that stretches back centuries. We are standing on the shoulders of giants, seeing farther because of the accumulated efforts of all who came before. The understanding of these cosmic forces does not belong to any individual. It belongs to humanity as a whole, a shared heritage of knowledge that transcends any single person or nation. It reminds us that, for all our insignificance on cosmic scales, we are the ones doing the asking, doing the looking, and doing the pushing. There is something deeply democratic about this pursuit of knowledge. Astronomical knowledge is available to anyone who wants it. You do not need to be wealthy or powerful to learn about the expansion of space. The information is out there, waiting for anyone curious enough to seek it out. The universe reveals itself to anyone who asks. I find this thought encouraging. In a world that often seems divided and contentious, the pursuit of cosmic knowledge is something that unites us. It does not matter what country you come from or what language you speak. The stars shine for everyone, and the truth about our expanding cosmos is the same truth everywhere. Science at its best is a cooperative endeavor that brings people together across all the boundaries that usually separate us. This gentle expansion of space is the breath of the universe. It is a quiet reminder that the cosmos is a dynamic, evolving place. We are drifting through an ever-expanding void, surrounded by mysteries that challenge our imaginations. But the fact that you can imagine it at all, that you can hold in your mind a picture of a universe stretching in every direction, driven by forces we are only just beginning to comprehend, is perhaps the most amazing thing of all. As we continue this journey, let yourself feel the wonder of being part of this grand cosmic dance. Let us drift back in time together, leaving behind the modern cosmos with its swirling galaxies and shining stars, and journey into the profound silence of the ancient past. When we talk about the expansion of the space between galaxies today, we are witnessing a gentle, quiet pushing, a part of the cosmos. But to truly understand the fabric of this vast reality, to comprehend what this expansion is made of, according to quantum physics, we must travel back to a moment so brief, so incredibly fleeting, that human language struggles to capture it. We must journey back 13,800,000,000 years to the very beginning of the universe itself. Imagine a time before light, before atoms, before the familiar structures of the cosmos had even been whispered into existence. This is the realm of the primordial universe, a place of infinite mystery and unimaginable density. When scientists look deeply into the night sky, they are essentially looking back in time, catching the ancient photons that have traveled across the endless void. And as they peer further and further back, they encounter a puzzle that fundamentally challenges our understanding of the universe. If you look at the cosmic microwave background, the fading afterglow of the Big Bang, you will notice something deeply counterintuitive. The temperature of this ancient light is almost exactly the same in every direction you look, down to a tiny fraction of a degree. This might seem normal at first glance, but it presents a profound paradox. The universe is so incredibly vast that regions on opposite sides of our observable sky have never had the time to communicate with each other, even at the speed of light. Light is the fastest thing in the universe, traveling at 186,000 miles per second. Yet, the distance between these opposite horizons is so immense that not even light has had enough time since the dawn of creation to cross it. So, how do two completely disconnected regions of the cosmos know exactly what temperature to be? How did they perfectly synchronize their heat before the universe even had time to take a breath? The answer to this beautiful mystery lies in a concept known as cosmic inflation, a theoretical event so powerful and rapid that it reshapes our entire understanding of reality. In the late 20th century, theoretical physicists proposed that in the very first fraction of a second after the Big Bang, the universe underwent an exponential, hyper-accelerated expansion. When I say a fraction of a second, I am not talking about a blink of an eye. I am talking about an interval of time so infinitesimally small that it requires the language of mathematics just to express. Scientists estimate that this period of cosmic inflation began around 10 to the power of minus 36 seconds after the universe was born and ended at roughly 10 to the power of minus 32 seconds. To put that into perspective, if you took a single second and divided it into a trillion equal parts, and then took just one of those tiny parts and divided it into a trillion parts again, and then did that once more, you would be approaching the timescale of cosmic inflation. During this incomprehensible sliver of a moment, the universe did not just expand, it exploded outward at a rate that vastly exceeded the speed of light. Now, you might recall that nothing can travel through space faster than the speed of light. But cosmic inflation was not a matter of objects moving through space. It was space itself, expanding, stretching the very fabric of the cosmos at a mind-boggling velocity, a region of space smaller than a single proton, smaller than the smallest quantum particle you can imagine, suddenly inflated to become larger than a grapefruit, and then larger than a galaxy, and then larger than the entire observable universe, all in less time than it takes for a beam of light to cross the width of an atom. It is a concept that produces a deep sense of awe, a staggering testament to the sheer power and scale of the natural world. But what does this have to do with the strange, microscopic world of quantum physics? This is where the story becomes truly poetic, bridging the gap between the infinitely small and the infinitely large. Remember those quantum fluctuations we discussed earlier, the tiny, restless particle, pairs constantly popping into existence and annihilating each other in the vacuum of space. In the normal universe, these quantum jitters are confined to the microscopic realm, canceling each other out in the quiet darkness. They are ephemeral, fleeting whispers of energy that never leave a lasting mark on the macrocosm. But during the epoch of cosmic inflation, the rules were different. The expansion of space was so violent, so incredibly rapid, that these microscopic quantum fluctuations were suddenly caught in the cosmic stretch before they had the chance to annihilate and disappear back into the void. The space containing them was ripped outward. These tiny quantum ripples, the smallest irregularities in the fabric of nature, were frozen in place and magnified to macroscopic scales. They were stretched across the expanding universe, becoming vast regions of slightly higher and slightly lower density. Let that sink in for a moment. The gentle irregularities in the quantum vacuum, fluctuations so incredibly small that they defy human intuition, were transformed by cosmic inflation into the foundational blueprint of the entire universe. Those slightly denser regions had just a tiny bit more gravitational pull than the emptier regions around them. Over billions of years, that microscopic difference in gravity began to pull matter together. Atoms coalesced into clouds of gas ignited into stars, and stars gathered by the billions to form galaxies, clusters, and the sweeping superclusters that light up our night sky today. Every galaxy you can see through a telescope, every star that twinkles in the dark canopy of the night, every planet that orbits those distant suns, and indeed every atom in your own body traces its origin back to those primordial quantum fluctuations. The largest structures in the cosmos are literally the magnified ghosts of the smallest quantum events. As the brilliant astronomer Carl Sagan once elegantly observed, the cosmos is within us. We are made of star stuff. But we can take that profound thought even further. We are made of quantum fluctuations. The very structure of our vast universe, the arrangement of the galaxies that form the cosmic web, is a giant, frozen picture of the quantum subatomic world from the first instant of creation. The macrocosm is a mirror of the microcosm, reflecting the deep, underlying unity of nature. This realization brings a profound sense of peace and humility. It teaches us that the immense and the minute are intimately connected. The universe is not a collection of isolated phenomena, but a single, continuous fabric where the smallest jitter of a subatomic particle can dictate the placement of a galaxy with 100 trillion stars. When we look at a distant galaxy, a cosmic monster stretching millions of light years across the void, we are actually looking at the consequence of a microscopic quantum event that happened 13,800,000,000 years ago. The silence of the night sky is not empty. It is a resonant echo of that original, sudden expansion. It is a quiet memorial to the briefest moment in history, a moment that set the stage for everything that would ever exist. The energy that drove this incredible expansion, the fuel for cosmic inflation, is another profound mystery. Physicists call it the inflaton field, a hypothetical energy field that permeated the early universe. Like dark energy today, this inflaton field possessed a kind of repulsive gravity, pushing space apart with unimaginable force. For reasons we do not yet fully comprehend, this field was highly unstable. It sat at a state of high energy, like a ball resting precariously at the very top of a steep hill. And just like that ball, it was destined to roll down. When the inflaton field eventually decayed, tumbling down to a lower energy state, it released all of its pent up energy into the universe. This sudden release of energy is what we traditionally call the Big Bang. It created a fiery, dense soup of elementary particles and radiation, the raw materials that would eventually cool and evolve into the cosmos we inhabit today. Inflation explains so many of the paradoxes that once troubled astronomers. It explains why the universe is so incredibly uniform on large scales. Because before inflation happened, all of space was compressed into a tiny, intimately connected region that had plenty of time to equalize its temperature. It explains why space appears so perfectly flat, as the sheer scale of the expansion stretched out any initial curves or warps in the fabric of spacetime, much like blowing up an enormous balloon makes its surface appear flat to a tiny ant walking upon it. And most beautifully, it explains the origin of structure, providing the quantum seeds that would eventually bloom into galaxies. It is a theory of staggering elegance, taking the chaotic, uncertain world of quantum mechanics and using it to paint the grandest masterpiece imaginable. Yet, for all its explanatory power, cosmic inflation remains a theory, a brilliant mathematical framework that still holds deep secrets. What exactly was the inflaton field? What caused it to start expanding in the first place? And perhaps, most tantalizingly, did inflation only happen once? Some theoretical physicists suggest that the process of inflation might be eternal. In this view, our entire universe is just a single, expanding bubble in a much larger, endlessly inflating multiverse. While inflation stopped in our particular bubble, allowing matter and galaxies to form, it might be continuing forever in the vast spaces between universes, constantly spawning new realms of existence with their own unique physical laws. This idea of an infinite, ever growing multiverse expands our sense of wonder to absolute breaking points, challenging us to imagine a reality far grander than anything our ancestors could have ever dreamed. As we sit here, safe on our small, rocky planet, drifting through the gentle silence of our solar system, we are participants in this grand cosmic story. We are the conscious observers, the ones who look back across the billions of years and piece together the history of the void. We are the universe trying to understand its own quantum origins. Every time we point a telescope at the fading light of the cosmic microwave background, we are listening to the faint whispers of creation. Every time we study the strange rules of quantum physics in a laboratory, we are exploring the very rules that built the stars. The journey to understand cosmic inflation is not just a scientific endeavor, it is a deeply philosophical and spiritual quest. It is a search for our ultimate beginnings, a desire to trace our lineage back through the eons, past the galaxies, past the first stars, past the glowing gas of the early universe, all the way back to a microscopic quantum ripple in a fraction of a second of hyper-accelerated time. It is okay to feel overwhelmed by these concepts. The human brain, evolved to track seasons and find food, was not designed to intuitively grasp numbers like 10 to the power of minus 36 or distances spanning billions of light years. But the fact that we can stretch our minds to even conceptualize these ideas is a beautiful testament to the power of human curiosity. We do not need to fully understand the mathematics of the inflaton field to feel the quiet awe that it inspires. We only need to look up to feel the vastness of the sky above us and to recognize that the boundless universe we see is intricately woven from the smallest, most ephemeral quantum threads. Let us rest here for a moment in this space of contemplation. Let the sheer scale of the ancient universe wash over you like a gentle tide. There is no rush to solve every mystery today. The cosmos has been unfolding for nearly 14 billion years, and it will continue to dance long after we are gone. The beauty lies not in having all the answers, but in the willingness to ask the profound questions. The unknown is not something to be feared. It is an infinite frontier inviting us to explore, to learn, and to grow. The tension between what we know and what remains undiscovered is the very engine of scientific discovery, driving us ever forward into the beautiful dark. As we prepare to continue our journey, to delve deeper into the nature of the quantum particles that make up our world and how they interact with the vastness of space, remember that you are an integral part of this magnificent structure. The same laws of physics that govern the swirling galaxies and the infinite multiverse also govern the beating of your heart and the firing of your neurons. You are a child of cosmic inflation, a complex, self-aware arrangement of stardust capable of looking back at the universe and marveling at its splendor. Keep this sense of wonder close to you as we navigate the mysteries ahead. Have you ever looked at a perfectly still pond on a windless evening and realized that beneath that glassy, mirroring surface, an entire ecosystem is teeming with invisible life and chaotic motion? The vacuum of space, the very emptiness that lies between the stars and galaxies, is much like that deceptive pond. We look up at the night sky and see a quiet, dark void, a profound silence that seems entirely devoid of substance. But quantum physics tells us a different, far more astonishing story, one that challenges our most basic perceptions of reality and invites us to rethink what it means for something to exist at all. To understand what cosmic inflation is truly made of, we must first unlearn what we think we know about nothingness. In our everyday human experience, an empty box is simply a box with nothing inside it. If you take away all the air, all the dust, every single atom, you believe you are left with a perfect vacuum. But in the strange, microscopic realm of quantum mechanics, a perfect vacuum is a physical impossibility. The universe simply does not allow for absolute emptiness. Let us pause for a moment to appreciate this quiet realization. Before we dive deeper into the boiling ocean of the quantum vacuum, I want to gently remind you that you are listening to Walter, the explorer. We are navigating these ancient mysteries together, but I have noticed that 73% of the wonderful people who watch these cosmic journeys have not subscribed to our channel yet. If you are finding peace and wonder in our quiet explorations, please consider subscribing. It helps our community grow, and it lets me know that you want to keep exploring the universe together. Thank you for walking this path with me. Now, let us return to the strange, vibrant nature of empty space. The great physicist Werner Heisenberg showed us through his famous uncertainty principle that we can never precisely know all the properties of a quantum system at once. We cannot simultaneously know the exact energy of a system and the exact time it possesses that energy. This fundamental uncertainty means that the energy of nothing cannot be exactly zero. If a region of space had exactly zero energy, there would be no uncertainty, which the laws of quantum physics strictly forbid. Instead, the baseline energy of space is constantly fluctuating. Stephen Hawking once noted that no matter how empty space may seem, it is never truly empty. Instead, the vacuum is a churning, bubbling sea of virtual particles. These particles, often particle antiparticle pairs, like an electron and a positron, spontaneously pop into existence, borrowing a tiny amount of energy from the vacuum itself. They exist for a fleeting fraction of a second, an incredibly short lifespan, and then they annihilate each other, returning the borrowed energy back to the void. This eternal dance of creation and destruction happens everywhere, all the time, in every cubic centimeter of the universe. It is the heartbeat of the cosmos, a quiet, continuous rhythm that hums beneath the threshold of our perception. Now, imagine this boiling quantum sea during the very first moments of the universe, just before cosmic inflation began. The space that contained our nascent universe was unimaginably small, dense, and hot, but it was still subject to these quantum rules. It was permeated by invisible energy fields. In quantum field theory, every type of particle has an associated field that stretches across the entire universe. There is an electromagnetic field, an electron field, a quark field, and, crucially for our story, the hypothesized inflatant field. To grasp the mechanism of cosmic inflation, physicists suggest that the early universe was trapped in what they call a false vacuum. Imagine a serene mountain lake held high by a dam. The water is calm, but it is in a state of high potential energy. It wants to flow downward, but is temporarily trapped. A false vacuum is similar. It appears empty and stable, but actually contains a massive amount of pent up, intrinsic energy. The inflaton field was resting in this high energy state, unable to immediately reach its lowest, most stable energy level, which we call the true vacuum. This intrinsic energy of the false vacuum acted entirely differently from the gravity we experience every day. Instead of pulling matter together, the energy of the false vacuum generated a colossal, repulsive gravitational force. This is the very engine of cosmic inflation. The false vacuum pushed outward, causing the fabric of space to stretch at an exponential rate. Here is the most counterintuitive part. As space expanded, the energy density of the false vacuum did not dilute. Because the energy was a fundamental property of space itself, creating more space simply created more energy. During this hyper-accelerated expansion, those tiny, ephemeral, virtual particles that were constantly popping in and out of existence experienced something extraordinary. Normally, a virtual particle and its antiparticle would annihilate each other almost instantly. But during inflation, space was expanding so violently and so rapidly that the two particles were suddenly torn apart, separated by distances expanding faster than the speed of light. They could no longer find each other to annihilate. They were ripped from the microscopic quantum realm and frozen into the macroscopic fabric of the expanding universe. These frozen quantum fluctuations became the microscopic variations in the density of the universe. In some regions, there was a tiny bit more energy, and in others, a tiny bit less. When inflation ended and the inflaton field rolled down to its true vacuum state, that pent up energy converted into a fiery bath of real particles and radiation. We typically think of this as the Big Bang, but the tiny density variations created by those stretched quantum fluctuations remained. They were the primordial seeds of structure. Over billions of years, gravity began its slow work. Regions with slightly more mass exerted a stronger gravitational pull, drawing in surrounding gas and dark matter over immense spans of time. Eventually, these dense pockets collapsed to form the first stars, which then gathered to form galaxies. The vast cosmic web of galaxy clusters and superclusters that we observe today, stretching across billions of light years, is nothing less than a magnified map of the quantum vacuum from the first fraction of a second of time. It connects the physics of the unimaginably small with the cosmology of the infinitely large. When we point our telescopes at the farthest reaches of the ancient cosmos, we are actually looking through a cosmic microscope at the fundamental quantum nature of reality. The vastness of the universe is a canvas upon which the strange, uncertain rules of subatomic particles have been painted on a grand scale. Sitting with this knowledge invites a deep sense of humility and peace. We are not just wandering blindly through a cold, disconnected void. We are embedded in a universe that is intricately connected across all scales of existence. The existence of our planet and the atoms in our bodies are direct consequences of virtual particles dancing in a false vacuum 13,800,000,000 years ago. Our existence is a beautiful, improbable echo of that ancient quantum rhythm. Yet, the mystery is far from solved. What exactly is this inflaton field? Why did it start in a false vacuum state? And what precisely triggered its decay? Researchers at NASA and brilliant minds across the globe are continuously searching for answers, studying the cosmic microwave background for subtle fingerprints of this era. But science does not seek to banish the mystery, it seeks to deepen it. Every new discovery opens the door to even more profound questions. We are perpetual students of the cosmos, learning to find comfort in the vastness of what we do not yet know. As we gaze up at the night sky, we are no longer just looking at a scattering of light. We are looking at the frozen echoes of quantum uncertainty. The quiet majesty of the universe is a testament to processes so elegant and so powerful that they defy our simple human intuition. We are part of this grand, unfolding story, conscious observers trying to piece together the puzzle of our own origins. Let us rest here, surrounded by the silence of the infinite, and allow the weight of these ancient mysteries to settle gently within us. The journey of discovery is a slow path, and there is immense beauty in simply walking it together to marvel at the profound strangeness of our reality. In the next part of our exploration, we will look closer at the moment inflation ended and how the scattered energy of the vacuum transformed into the matter that forms our world. Have you ever held a warm cup of tea on a cold winter morning and wondered about the hidden journey of that heat? You feel the gentle warmth spreading through your hands, bringing a quiet comfort against the chill of the air. But where did that energy truly come from? And what does it mean for energy to exist in our vast, ancient universe? We often take the physical world for granted. We touch a table and feel its solid reality. We breathe the air and trust in its invisible presence. We are used to a universe filled with stuff, with matter, with particles that combine to form everything from the smallest grain of sand on an endless beach to the most massive galaxy swirling in the dark void. But quantum physics tells us a story that challenges our deepest intuitions about reality. There was a time, a fleeting, incomprehensible fraction of a second in the deep past, when the universe contained absolutely no matter at all. There were no atoms, no protons, no electrons, and certainly no stars or planets. There was only the stretching fabric of space and the immense, pent up energy of the quantum vacuum. The transition from that empty, inflating void to a cosmos filled with the building blocks of life is perhaps the most profound mystery in all of science. It is the story of how the universe literally materialized out of the energy of empty space. Before we witness the quiet birth of the very first particles that would eventually become you and me, I would like to gently pause our journey for a brief moment. Hello again, my fellow traveler. I am Walter, the explorer, and it is a deep privilege to share this quiet journey through the infinite cosmos with you. As we navigate these profound mysteries together, I have noticed that 73% of the wonderful people who watch these meditative cosmic journeys have not subscribed to our channel yet. If you are finding a sense of peace, wonder, and intellectual safety in our stories, please consider taking a moment to subscribe. It helps our community of curious minds grow, and it lets us know that you want to keep exploring the grand mysteries of the universe together. Thank you for your kindness and for sharing your time with me. Now, let us return to that ancient moment when the universe finally stopped expanding at that terrifying, hyper-accelerated rate, and the cold void suddenly transformed into a brilliant sea of light. The epoch of cosmic inflation, as we have discovered, was driven by the inflaton field, an unstable, high-energy state of the quantum vacuum. For a trillionth of a trillionth of a trillionth of a second, this field acted like a stretched rubber band, pushing space apart faster than the speed of light. But nothing in the natural world can remain in a state of unstable, false vacuum forever. Eventually, like a ball rolling down a steep hill into a valley, the inflaton field decayed. It plummeted to its lowest energy state, the true vacuum that we experience today. When a stretched rubber band snaps back, or when a ball rolls down a hill, energy is released. In the case of the inflaton field, the amount of potential energy that had been locked up in the fabric of space itself was staggeringly large. When inflation abruptly ended, all of that energy had to go somewhere. It could not simply vanish, because the most fundamental law of physics dictates that energy is never truly lost. It merely transforms. And transform it did in an event of such unimaginable power and subtle beauty that it defines everything we know as reality. Cosmologists call this brief, transformative period reheating. But the word reheating is almost a gentle understatement for the most dramatic metamorphosis in cosmic history. When the inflaton field collapsed, its enormous energy was dumped directly into the other quantum fields that permeate the universe. To understand this, we must picture the universe not as an empty room containing objects, but as a vast, quiet ocean composed of many different overlapping fluids. There is a fluid for the electromagnetic force, a fluid for electrons, a fluid for quarks, In the language of quantum mechanics, these fluids are called quantum fields. When a quantum field is perfectly still, we perceive empty space. But when a quantum field vibrates, when it is excited by an injection of energy, those ripples manifest in our physical reality as particles. The decay of the inflaton field was like a massive cosmic stone being dropped into the completely still, overlapping oceans of the quantum fields. Instantly, the quiet, cold, empty universe was flooded with violent vibrations. The energy of the expanding vacuum was entirely converted into a searing, blindingly hot plasma of fundamental particles. This is the true Big Bang. It was not an explosion of matter outward into an empty space, but rather an explosion of energy vibrating within the fabric of space itself. Out of the pure, abstract mathematics of quantum energy, the physical building blocks of the cosmos were born. Quarks, electrons, neutrinos, and photons flooded the universe in numbers so vast they defy any attempt at human comprehension. The temperature of the cosmos skyrocketed to billions upon billions of degrees. It was a chaotic, dense, boiling soup of creation, a primordial forge, where the very concepts of light and matter were inextricably tangled together in a brilliant, chaotic dance. This moment of reheating is a profound paradox that challenges our understanding of existence. Everything that currently has mass, everything that feels solid and real to your touch, is ultimately the frozen, cooled down energy of a decaying quantum field. As the great physicist Albert Einstein famously demonstrated with his beautiful equation equating energy and mass, the two concepts are simply different expressions of the exact same underlying reality. Matter is essentially highly concentrated, condensed energy. When the universe was born, it took the expansive, repulsive energy of the void and condensed it into the tiny, vibrating points of reality we call particles. The sheer scale of this transformation produces a deep sense of respectful wonder. The entire mass of the 100 trillion stars in the biggest galaxy we have ever discovered, along with the 2 trillion other galaxies scattered across the observable universe, was all spun out of the invisible, ethereal energy of the vibrating quantum vacuum. As this primordial soup of newly born particles expanded, it began a long, slow, quiet journey of cooling. The universe is a master of patience. It does not rush. As space continued to expand, no longer driven by the hyper-accelerated force of inflation, but merely drifting on the momentum of that initial push, the temperature of the cosmos began to drop. The boiling ocean of quarks and electrons gradually lost its searing heat. This gentle cooling was absolutely necessary for the creation of complexity. In a universe that is too hot, particles are moving too violently to ever stick together. They smash into one another with such force that any bonds are instantly shattered. It is a state of eternal chaos where nothing permanent can ever be built. But as the deep silence of space expanded, the fiery energy of the particles stretched and cooled, allowing a new phase of cosmic evolution to begin. About 1 millionth of a second after the inflaton field decayed, the universe had cooled just enough for a profound shift to occur. The quarks, those tiny, fundamental fragments of matter that had been swimming freely in the dense plasma, suddenly found that they lacked the energy to escape one another. The strong nuclear force, one of the fundamental rules woven into the fabric of reality, reached out and bound them together. In a cosmic blink of an eye, the free roaming quarks were locked away inside slightly larger structures. They formed protons and neutrons, the heavy, stable hearts of what would eventually become atoms. This was the universe taking its very first step toward building the solid, reliable reality we experience today. The chaos was beginning to organize itself. The abstract energy of the quantum fields was slowly condensing into the tangible architecture of matter. This progression from abstract energy to solid matter is not just an ancient historical event, it is a deeply personal story. The protons that were forged in that cooling quantum soup less than a single second after the beginning of time are incredibly stable. Some theories of physics suggest they might last for 10 to the power of 34 years, a time span so infinite that our minds cannot even begin to grasp its edges. This means that the protons sitting quietly in the center of the oxygen atoms you are breathing right now, the protons in the iron coursing through your veins, and the protons in the screen you're watching were all created in that exact moment of cosmic reheating. They have survived for 13,800,000,000 years, drifting through the deep, silent void, gathering into stars, being blasted out into space by supernovas, and eventually coalescing to form our beautiful, fragile Earth. You are carrying the ancient, cooled embers of the quantum vacuum within your very cells. When we look up at the vastness of the night sky, we are not looking at something separate from ourselves. We are not outsiders gazing upon a cold, mechanical machine. We are the universe observing itself. We are the direct, unbroken continuation of that first, fiery moment when energy transformed into matter. Our capacity for curiosity, our deep need for peace, and our ability to feel wonder are all emergent properties of those primordial quantum fields. The cosmos is not just around us, it is fundamentally who and what we are. The tension between the known and the unknown, between our everyday human experience and the astonishing reality of our quantum origins, is an invitation to explore without fear. It is a reminder that even the most complex, intimidating mysteries of physics are ultimately stories about our own deep history. As the universe continued to expand and cool over the next several 100,000 years, the newly formed protons and the still roaming electrons remained locked in a dense, glowing fog. Light could not travel freely. It was constantly absorbed and re-emitted by the thick soup of particles. The universe was an opaque, glowing wall of heat, but patience, as always, guided the cosmos. The expansion continued, the temperature dropped further, and the stage was set for another breathtaking transformation, a moment of profound revelation when the universe would finally become transparent, and the very first light would break free to begin its eternal journey across the endless, silent dark. We will quietly explore this dawn of light and how it carries the secrets of the universe directly to our telescopes in the next part of our shared journey. Let yourself rest in the knowledge that you are a complex, beautiful expression of the ancient cosmos, woven from the stardust and quantum fields of the deep past. Have you ever stood outside on a cool, damp morning, entirely enveloped in a thick, gray fog? You look around, and your vision is limited to just a few feet. The world feels small, intimate, and opaque. You cannot see the distant hills, the sprawling trees, or the horizon. The air itself seems to be glowing with a soft, scattered light, hiding the vastness of the landscape behind a veil of mist. Then, as the morning sun slowly warms the air, the fog begins to lift. Almost like magic, the veil dissolves, and suddenly the endless expanse of the world is revealed to your eyes. The universe, in its deep, ancient past, experienced a morning just like this for hundreds of thousands of years after the dramatic events of cosmic inflation and the fiery birth of the first particles. The entire cosmos was trapped in an impenetrable fog. It was a universe filled with light, yet completely blind. This paradox is one of the most beautiful mysteries of quantum physics and cosmology, a story of how the cosmos finally opened its eyes and allowed the first light to travel freely across the infinite, quiet void. Before we witness the lifting of this primordial fog, let us take a gentle breath together and appreciate the stillness of this moment. Hello, my fellow traveler. I am Walter, the explorer, and it is a true joy to be your gentle guide on this journey through the deep cosmos. I have noticed something surprising as we wander through these mysteries together. 73% of the wonderful people who watch these quiet, meditative explorations have not subscribed to our channel yet. If you are finding a sense of peace, intellectual safety, and wonder in our stories, please consider subscribing. It helps our community grow, and it lets us know that you want to keep exploring the grand, ancient universe together. Thank you for your kindness and your shared curiosity. Now, let us return to that dense, glowing fog of the early universe and discover the exact moment when the darkness of space was finally born. To understand this opaque era, we must remember what the universe was made of just after the inflaton field decayed. It was a boiling, churning plasma. In this extreme heat, atoms could not exist. The protons and electrons, the tiny building blocks of matter, were moving too fast, energized by the searing temperature. Whenever an electron tried to settle into an orbit around a proton, a high energy photon of light would immediately smash into it, knocking it away. Because the universe was packed so densely with these loose, frantic electrons, light simply could not travel. A photon would travel a microscopic distance before bouncing off an electron, then another, in a relentless pinball game. If you could somehow stand in that ancient universe, you would not see stars or galaxies. You would be immersed in a blinding, uniform, featureless glow. The universe was a continuous, unbroken wall of brilliant, scattered light. There were no shadows, no shapes, and no deep, quiet darkness. But the cosmos is patient. It operates on a scale of time that invites us to slow down and find peace in the gradual unfolding of reality. As the universe continued its gentle, relentless expansion, stretching the fabric of space across unimaginable distances, the temperature steadily dropped. The fiery chaos of the plasma slowly began to calm. This cooling process was not a sudden event, but a majestic, quiet settling that took place over 380,000 years. In the grand timeline of a universe that is now 13,800,000,000 years old, 380,000 years is merely a blink of a cosmic eye. Yet, for the particles trapped in that glowing fog, it was an eternity of frantic bouncing and colliding, an endless ocean of scattered energy, waiting for a moment of profound transformation. Then, a fundamental threshold was reached. The temperature of the expanding cosmos dropped to roughly 3,000 degrees. At this precise, beautiful turning point, the quantum dance changed its rhythm entirely. The photons of light had finally lost enough energy, stretched and weakened by the expansion of space, that they could no longer smash the electrons away from the protons. The electromagnetic force, a gentle but insistent rule of nature, reached out and embraced the particles. In a process scientists call recombination, the electrons were finally able to slow down and enter quiet, stable orbits around the protons. The very first atoms of neutral hydrogen and helium were born. The frenzied, loose electrons were suddenly swept up and organized, locked away inside these new, stable atomic structures, leaving the spaces between them empty and serene. This moment of atomic birth changed the universe in a profound and permanent way. With the free electrons suddenly gone, neatly tucked away inside hydrogen atoms, the fog instantly vanished. The obstacle course was cleared. For the first time in the history of existence, light could travel in a straight line. The photons that had been bouncing endlessly in the primordial plasma were suddenly set free, unleashed to fly across the infinite expanse of space. The universe became transparent. The blinding, opaque glow was replaced by the deep, silent darkness that we recognize today when we look up at the night sky. But that original light did not disappear. It was simply stretched out, carrying the fingerprint of creation with it as it began a journey that would last for billions of years, crossing the vastness of the expanding void to eventually reach our tiny world. That very first burst of liberated light is still traveling through the cosmos today. It is all around us, washing over the earth in a constant, invisible tide. We call it the cosmic microwave background radiation because the universe has been expanding for nearly 14 billion years since that light was released. The photons have been stretched, their wavelengths pulled out into the microwave region of the electromagnetic spectrum. You cannot see it with your eyes, but it is there, an ancient echo of the moment the fog lifted. When you tune an old television set between channels and see that random black and white static, a small percentage of that static is actually the direct interaction of your television antenna with the cosmic microwave background. You are literally witnessing the glowing embers of the Big Bang, the cooled down residue of the quantum vacuum, right in your living room. A quiet reminder of our deep origins. The discovery and mapping of this ancient light is one of the greatest triumphs of human curiosity. Brilliant scientists and engineers at space agencies like the National Aeronautics and Space Administration and the European Space Agency have launched incredibly sensitive instruments into the cold void of space to capture this faint glow. Satellites like the Cosmic Background Explorer, the Wilkinson Microwave Anisotropy Probe, and the Planck spacecraft have patiently scanned the heavens, collecting the oldest photons in existence. What they found was a masterpiece of cosmic history. They created a map of the entire sky, showing the tiny, subtle variations in the temperature of that original light, revealing the hidden structure of the early cosmos. When you look at the map of the cosmic microwave background, you are looking at a baby picture of the universe. The tiny temperature differences, measuring just fractions of a degree, correspond perfectly to the quantum fluctuations that were frozen into the fabric of space during the hyper-accelerated era of cosmic inflation. The slightly warmer spots represent regions where matter was just a little bit denser, and the slightly cooler spots represent regions that were a little bit emptier. As the renowned astrophysicist Neil deGrasse Tyson has elegantly pointed out, we are chemically connected to all molecules on Earth, and we are atomically connected to all atoms in the universe. But when we look at the cosmic microwave background, we see that we are also gravitationally and quantum mechanically connected to the very dawn of time. Those microscopic, ancient quantum ripples are the exact seeds that gravity eventually pulled together to form the vast galaxy clusters, the shining stars, and the quiet, rocky planet we call home. This understanding brings a profound sense of humility and intellectual safety. We do not need to be intimidated by the scale of the cosmos. Instead, we can find peace in the realization that we are an integral part of this grand, continuous story. The light from that ancient dawn has traveled for 13,800,000,000 years, crossing a vast, silent ocean of expanding space, just to reach our instruments, our eyes, and our minds. It is a gentle reminder that the universe is not hiding its secrets from us. It is broadcasting its history in every direction, inviting anyone with enough curiosity and patience to listen to its ancient song. The mystery of what cosmic inflation is made of leads us back to these fundamental questions about light, matter, and empty space. We have traced the journey from the boiling quantum fluctuations of the false vacuum through the fiery decay of the inflaton field to the sudden clearing of the primordial fog. We have seen how the universe builds complexity out of chaos, using the strict but beautiful rules of quantum physics to shape the macrocosm. Every atom in your body was once part of that opaque, glowing plasma. The energy powering your thoughts is a transformed echo of the energy that drove the exponential expansion of space, connecting you directly to the very first moments of creation. In the next part of our exploration, we will journey into the cosmic dark ages, a period of deep, profound silence that lasted for hundreds of millions of years, before gravity finally summoned the strength to ignite the very first stars. We will witness the universe slowly waking up, building the cosmic web that connects everything we know. Rest now, and let the ancient, invisible light of creation bring you peace as we prepare for the next step in our shared voyage through the quiet, endless wonder of the universe. Have you ever found yourself sitting in a room after the sun has set, watching the last fading embers of daylight disappear until you are enveloped in complete and absolute darkness? In our modern world, we are so accustomed to artificial light that true, unbroken darkness can feel unsettling, perhaps even a little frightening. We are creatures of the day, seeking illumination and clarity. But if we want to truly understand the grand story of the cosmos and the profound legacy of cosmic inflation, we must learn to find peace in the dark. We must embrace the silence. Following the release of the cosmic microwave background, when the first atoms formed and the primordial fog finally lifted, the universe did not immediately burst into a dazzling display of starry galaxies. Instead, it entered a period of profound and quiet waiting. Astronomers call this era the cosmic dark ages. For hundreds of millions of years, there was no starlight at all. The universe was an ever-expanding, cooling void filled almost entirely with invisible clouds of neutral hydrogen and helium gas. It was a time of immense, stretching emptiness, an ancient epoch where the universe simply rested, holding its breath in the infinite silence. Let us pause here, in this quiet darkness, for a brief moment. Hello again, my wonderful friend. I am Walter, the explorer, and I am deeply grateful to be sharing this gentle journey through the vast mysteries of space with you. As we navigate these silent cosmic seas together, I want to gently mention that 73% of the wonderful people who watch these meditative videos have not subscribed to our channel yet. If you are finding comfort, intellectual safety, and a sense of deep wonder in our shared explorations, please consider taking a moment to subscribe. It truly helps our community grow, and it lets me know that you want to keep unraveling the beautiful secrets of the universe together. Thank you for your warmth and your continued curiosity. Now, let us return to the cosmic dark ages and discover how the microscopic quantum ripples of inflation finally began to build the massive structures of our world. In that absolute darkness, a slow and silent drama was unfolding. Remember those microscopic quantum fluctuations, the tiny, ephemeral variations in the false vacuum that were frozen and stretched to cosmic proportions during inflation? These invisible ripples were the most precious inheritance the early universe received. They were the blueprints for everything that would follow. As the cosmos expanded and cooled, these slight variations in density began to exert a subtle but undeniable influence. In the regions where the dark matter and the hydrogen gas were just a tiny bit denser, the gravitational pull was just a tiny bit stronger. Gravity, the great sculptor of the universe, began its patient, quiet work. Over millions upon millions of years, these denser pockets of gas began to pull more and more material toward them. The universe builds things from the bottom up, starting small and growing large. Through countless merges over cosmic time, small galaxies form first from collapsing clouds of primordial gas. Imagine a vast, invisible web stretching across millions of light years, woven from strands of dark matter and gas. In the deepest silence, this web was slowly tightening. The hydrogen gas was being drawn into the gravitational wells created by those ancient quantum ripples. As the gas accumulated in these massive dark clouds, it began to compress, and as it compressed, it began to heat up. In the absolute frigid cold of the expanding cosmos, isolated pockets of intense heat were secretly gathering strength. The patience of the universe is staggering. It did not rush this process. It allowed gravity to pull, to compress, and to heat the hydrogen for hundreds of millions of years. This teaches us a beautiful lesson about our own human existence. We often seek immediate results, immediate illumination, but the cosmos shows us that the most profound transformations, the birth of the greatest wonders, require deep time and quiet patience. Eventually, deep within the densest cores of these collapsing gas clouds, the temperature and pressure reached a critical, miraculous threshold. The hydrogen atoms were squeezed together so tightly that they fused, igniting the fires of nuclear fusion. In the depths of the cosmic dark ages, a spark caught, and then another and another. The very first stars burst into brilliant life, piercing the primordial darkness with piercing, fierce, ultraviolet light. These first stars were nothing like our gentle sun. They were monstrous, massive giants, burning with a ferocious intensity and living incredibly short, dramatic lives before exploding in magnificent supernovas. But their light was the dawn of a new era, The Dark Ages were over, and the universe was finally illuminated. The light from these ancient suns streamed out into the void, interacting with the surrounding hydrogen gas and fundamentally changing the chemical makeup of the cosmos. This moment of first light is the direct result of cosmic inflation. If the universe had been perfectly smooth, if those quantum fluctuations had not been stretched into existence by the decaying inflaton field, gravity would have had no dense pockets to pull together. The hydrogen gas would have simply drifted evenly apart as the universe expanded, never clumping, never heating, and never igniting. The universe would have remained dark and empty forever. The fact that we exist, that we are sitting here on a rocky planet warmed by a stable yellow star, is entirely because the vacuum of space is not truly empty, and because the universe underwent that hyper accelerated expansion in its first fleeting fraction of a second. Every photon of light warming your face on a sunny day is a distant, transformed echo of quantum uncertainty. As these first stars lived and died, their gravity pulled them together into the very first primitive galaxies. Those small galaxies then merged together to form larger ones. Larger galaxies merge to form even larger ones. And on it goes, with the biggest galaxies growing ever larger by consuming their smaller neighbors. This process is called hierarchical structure formation, and it is one of the fundamental principles of modern cosmology. Through billions of years of cosmic history, these early structures collided, combined, and grew into the majestic spiral and elliptical galaxies we observe today. We now know that our galaxy was not the whole cosmos. It was just one galaxy among many. Today, we estimate that there are around 2 trillion galaxies in the observable universe. Each of those galaxies contains billions or even trillions of stars. But the story of cosmic inflation and the expansion of the universe does not end with the birth of the first stars and galaxies. The fabric of space is still expanding, and this expansion is carrying the galaxies away from each other. For most of the 20th century, astronomers assumed that the expansion of the universe was slowing down, but the universe is full of surprises. We now know that the universe is not slowing down. It is speeding up, and the rate of expansion is accelerating over time. This acceleration is driven by something scientists call dark energy, a mysterious force that makes up about 68% of the total energy in the universe, but whose nature we do not understand at all. We know that it acts as a kind of anti-gravity, pushing space apart rather than pulling it together. The connection between the inflaton field that drove the early, rapid expansion and the dark energy that is driving the current acceleration is one of the most profound mysteries in physics. As we contemplate the cosmic dark ages and the brilliant dawn that followed, we can find a deep sense of peace. The universe went through a long, dark night before it could shine. It required the invisible, quiet work of gravity and quantum mechanics to build the beauty we see today. If you are going through a period of darkness or waiting in your own life, you can draw comfort from the cosmos. The greatest structures in the universe were born from darkness and patience. The gentle, ancient forces of creation are still at work, both in the vast expanse of space and within your own heart. We are the universe observing itself, experiencing the wonder of existence, and seeking to understand the infinite mystery of our own origins. In the next step of our journey, we will explore the bizarre counterintuitive rules of the quantum world that made all of this possible. We will look at how particles interact, how black holes fit into this expanding puzzle, and how these strange behaviors shape the very reality we experience every day. Let the quiet majesty of the expanding universe bring you comfort and serenity. Take a deep breath, feel the ancient stardust in your bones, and rest in the knowledge that you are a vital, beautiful part of this grand cosmic story. Have you ever pressed your hand against the rough bark of an ancient tree or felt the cool surface of a stone and marveled at its absolute solidity? Our senses tell us a very convincing story about the world. They tell us that matter is firm, that objects have distinct boundaries, and that the universe is made of solid, dependable stuff. But as we journey deeper into the mysteries of cosmic inflation and the quantum physics that birthed our reality, we must gently set aside this comforting illusion. The truth of what the universe is made of is far more beautiful and far stranger than anything our human hands can touch or our eyes can see. To understand the engine that drove the exponential expansion of the early cosmos, we must shrink our perspective down past the realm of cells, past the structure of molecules, and dive into the dizzying, uncertain depths of the subatomic world. At this microscopic scale, the solid world dissolves into a haze of probabilities and vibrating fields. The rules that govern our everyday lives simply cease to exist, replaced by a surreal choreography of energy and chance. Before we immerse ourselves completely in the strange and beautiful waters of the quantum realm, I would like to gently pause our journey. Hello once more, my fellow traveler. I am Walter, the explorer, and it is a deep honor to guide you through these quiet cosmic mysteries. As we sit together in the vastness of this shared curiosity, I have noticed that 73% of the wonderful people who watch these meditative explorations have not subscribed to our channel yet. If you are finding a sense of peace, intellectual safety, and deep wonder in our stories, please consider taking a gentle moment to subscribe. It helps our community of stargazers grow, and it lets me know that you want to continue walking this infinite path of discovery together. Thank you for your warmth and for opening your mind to the universe. Now, let us return to the hidden, microscopic foundation of our grand reality. When scientists in the early 20th century first began to peel back the layers of the atom, they expected to find tiny, hard spheres, like miniature billiard balls, bouncing around in predictable paths. Instead, they discovered a universe that seemed to actively resist being pinned down. They found that fundamental particles, like the electrons orbiting the nucleus of an atom or the photons of light traveling through the void, do not possess fixed positions or definite speeds until they are forced to interact with something else. Instead of being solid objects with clear edges, these fundamental building blocks of nature exist as smeared out waves of probability. Imagine a gentle ripple spreading across the surface of a quiet pond in the deep of the night. Before you dip your hand into the water to measure exactly where the peak of the wave is, the wave exists everywhere across the surface at once. In the strange quantum world, a particle exists in a state of multiple possibilities simultaneously, a bizarre and beautiful phenomenon known as superposition. It is incredibly difficult for our minds, which evolved over millions of years, to track predictable, trajectories of falling apples and moving animals. To truly grasp this concept, but this inherent fuzziness, this profound uncertainty at the base of all things, is not a flaw in our measurements. It is the fundamental, inescapable nature of reality itself. And it is this very uncertainty that provided the crucial spark for the entire universe. Remember the inflaton field, that mysterious ocean of energy that drove the hyper-accelerated expansion of space during the first fraction of a second of time. That ancient field was not a smooth, perfectly uniform sheet of energy. Because it was a fundamental quantum field, it was subject to the exact same rules of uncertainty and superposition that govern a single electron. The energy of the inflaton field was constantly jittering, fluctuating, and vibrating with microscopic waves of probability, bubbling in the absolute silence of the newborn cosmos. If the universe had simply expanded at a normal, gentle pace, these tiny quantum jitters would have remained forever trapped in the microscopic realm. They would have silently fluctuated in the dark, without ever affecting the macroscopic world we can see and touch. But cosmic inflation was a violent, exponential tearing of space itself, as the fabric of the universe stretched outward faster than the speed of light. It grabbed hold of those tiny, fuzzy waves of probability. It caught the inflaton field in the act of fluctuating and instantly, relentlessly, froze those microscopic jitters into macroscopic reality. A region of the quantum field that happened to be fluctuating with slightly higher energy was suddenly stretched to become a vast region of space, billions of light years across. A region with slightly lower energy became a colossal, empty void. The inherent, chaotic uncertainty of the subatomic world was permanently drawn onto the immense canvas of the cosmos. This means that the magnificent structures we observe through our telescopes today, the great walls of shining galaxies, the massive clusters bound together by gravity, and the vast, quiet voids that separate them, are quite literally the magnified shadows of quantum uncertainty. The largest scales of the universe are an exact, unbroken mirror of the smallest. There is a profound, poetic beauty in this scientific realization. The strict, deterministic laws of classical physics could never have created the complex, beautiful universe we inhabit. A perfectly smooth, predictable universe would have expanded into a featureless fog of evenly distributed gas. It took the inherent unpredictability of quantum mechanics, the gentle chaos of the subatomic world, to seed the empty cosmos with the potential for stars, planets, and ultimately conscious life to emerge. But the strange, counterintuitive rules of quantum physics did not just shape the initial distribution of matter, they also point to a deeper, almost mystical connectivity woven into the very fabric of space itself. In the quantum realm, there is a phenomenon that the brilliant physicist Albert Einstein famously referred to as spooky action at a distance. Today, we simply call it quantum entanglement. When two particles interact in a certain way, their quantum states become inextricably linked, merged into a single reality. They become a unified system, regardless of the physical distance that separates them. If you measure the properties of one entangled particle, you instantly know the properties of its partner, even if that partner is placed at the very opposite end of the observable universe. The connection is immediate, seemingly defying the absolute speed limit of light and suggesting that At a fundamental level, space and distance might be elaborate illusions. Now, let us bring this profound concept back to the fiery era of cosmic inflation. Before the hyper-accelerated expansion began, all the energy, all the matter, and all the boundless potential of our observable universe was packed tightly into a space far smaller than a single proton. In that incredibly dense, hot primordial state, all the quantum fields were intimately connected, overlapping and interacting in a state of profound unity. It is highly likely, according to our best mathematical models, that vast networks of quantum entanglement were established in that original microscopic seed of existence. Then, inflation happened. Space was ripped apart, expanding exponentially and carrying those entangled connections with it across the growing void. This presents a mesmerizing possibility that theoretical physicists are actively exploring today. If the particles and fields of the early universe were deeply entangled before being scattered across the cosmos by the force of inflation, then the immense universe we inhabit might still be crisscrossed by an invisible, underlying web of quantum connections. The very space that separates the stars might not be an empty, dead void, but a rich tapestry of entangled information. The deep silence of the cosmos might actually be filled with the quiet, instantaneous whispers of particles communicating across billions of light years of empty space. We are deeply accustomed to thinking of the universe as a collection of separate objects floating randomly in an empty box. But quantum mechanics, combined with the extreme stretching of cosmic inflation, paints a picture of a universe that is fundamentally one single, inseparable, breathing entity. This realization invites a profound shift in how we view our place within the grand cosmos. We are not alienated, lonely observers looking out at a cold machine that cares nothing for our existence. We are localized, conscious expressions of a deeply interconnected whole. The atoms in your body, governed by the fuzzy rules of quantum probability, are part of the exact same continuous fabric that stretches to the farthest galaxies. The feeling of separation that we experience in our daily lives, the sense that we are distinct and isolated from the rest of the natural world, is ultimately an illusion generated by the macroscopic scale at which our bodies operate. When we look deep enough, when we trace the lineage of reality back to the inflating quantum vacuum, we find only profound unity and an unbroken chain of existence. The pursuit of this cosmic knowledge is one of the most heroic intellectual journeys our species has ever undertaken. It requires us to abandon our common sense, to embrace dizzying paradoxes, and to find lasting comfort in the fact that reality is far stranger than we could have ever invented. We use massive machines like the particle accelerators operated by the European Organization for Nuclear Research to smash tiny atoms together at nearly the speed of light, desperately trying to recreate the searing heat and the quantum chaos of the Big Bang right here on Earth. We do this not just for the sake of accumulating cold data, but to answer a deep existential yearning within the human heart to know where we came from and what we are truly made of at the most fundamental level. It is perfectly natural to feel a sense of intellectual vertigo when contemplating these immense, boundary pushing ideas. The mind spins when trying to hold the concept of a particle being in two places at once, or a universe expanding faster than light itself, or a physical reality built entirely on the fluctuating energy of nothingness. But I gently invite you to let that intellectual vertigo transform into a gentle, respectful awe. You do not need to be a highly trained theoretical physicist to appreciate the profound poetry of the quantum universe. You only need to be willing to look past the comforting illusion of the solid world, to close your eyes, take a slow breath, and imagine the silent, vibrating ocean of energy that elegantly underpins everything you have ever known. As we rest here together, suspended safely between the infinite vastness of the cosmos and the microscopic mysteries of the quantum realm, let yourself feel a deep, abiding sense of peace. The universe is incredibly complex, but it is not malicious or chaotic. It operates according to profound, elegant rules that we are slowly, patiently beginning to understand through our shared curiosity. The unknown is vast, but it is a welcoming frontier that invites our exploration without judgment. In the next chapter of our journey, we will explore the strange and beautiful role of time in this expanding, quantum entangled cosmos. We will look at how the flow of time itself was shaped by the fires of the Big Bang. Until then, breathe deeply, feel the ancient quantum energy that gives life to your body, and rest completely in the profound quiet of the cosmic mystery. Have you ever sat quietly on a slow afternoon, watching the shadows stretch across the floor, and felt as though time itself had somehow slowed down to a gentle crawl? We experience time as a steady, relentless river, carrying us constantly forward from the past, through the present, and into the unpredictable future. Our human lives are deeply governed by the ticking of clocks, the turning of the seasons, and the gentle aging of our own bodies. We take for granted that time is a universal constant, an invisible backdrop against which the events of our lives simply unfold. But the universe, in its vast and ancient wisdom, does not experience time the way we do. As we journey deeper into the mysteries of cosmic inflation and the quantum foundations of our reality, we encounter a profound and unsettling truth. Time is not an absolute, unchanging rule. It is a flexible, deeply mysterious dimension that was profoundly shaped and perhaps even born in the fiery quantum forge of the early cosmos. The universe is full of mysteries that challenge our perception, and the mystery of time is perhaps the most beautiful of them all. Before we unravel the strange and beautiful tapestry of cosmic time together, let us take a gentle breath and appreciate the stillness of this very moment. Hello, my fellow traveler. I am Walter, the explorer, and it is a wonderful privilege to share this quiet, contemplative journey with you. As we drift through these infinite mysteries of the cosmos, I have noticed something surprising. 73% of the wonderful people who watch these quiet, meditative stories have not subscribed to our channel yet. If you are finding a sense of peace, intellectual safety, and deep wonder in our shared explorations, please consider taking a moment to subscribe. It truly helps our community of curious minds grow, and it lets me know that you want to continue walking this endless path of discovery together. Thank you for your warmth, your patience, and your companionship on this cosmic voyage. Now, let us return to the deep dawn of creation and discover how the universe learned to tick. To understand the nature of time in an expanding universe, we must first look through the brilliant lens of Albert Einstein. In his masterpiece of general relativity, Einstein revealed that space and time are not separate entities, but rather a single, interwoven fabric called space-time. This fabric is not rigid. It can be bent, stretched, and warped by the presence of mass and energy. The gravity that holds our feet to the Earth is actually the feeling of space-time curving around our planet. Because space and time are inextricably linked, the exponential expansion of space during the era of cosmic inflation was not just a physical stretching of distance, it was also a profound manipulation of time itself. When the unstable inflaton field drove the universe to expand faster than the speed of light, it stretched the very canvas upon which the flow of time is painted. The rapid tearing of the primordial vacuum was an event that reshaped the fundamental geometry of existence. But cosmic inflation was, at its heart, a quantum phenomenon, and in the strange, microscopic realm of quantum physics, time behaves in ways that utterly defy our human intuition. In our everyday macroscopic world, events happen in a strict sequence. A glass falls off a table, and then it shatters on the floor. You never see a shattered glass spontaneously reassemble itself and leap back onto a table. This one-way direction is what physicists call the arrow of time. But if you zoom in to the level of individual subatomic particles, to the realm of quarks and electrons dancing in the quantum vacuum, this rigid arrow of time seems to disappear entirely. The fundamental mathematical equations of quantum mechanics work perfectly well. Whether time is running forward or backward, at the absolute smallest scales of reality, the distinction between the past and the future begins to blur into a profound, vibrating haze of probabilities. The subatomic world is symmetric in time, an eternal dance of energy that cares nothing for past or future. This leads us to one of the most dizzying and magnificent mysteries of cosmology. What was time doing before the universe began? If the cosmos was compressed into an infinitely dense, perfectly uniform quantum state, a singularity where the laws of physics as we know them break down, did time even exist? Many theoretical physicists suggest that the concept of time itself might be an emergent property of the universe, something that only came into being when the universe began to expand and evolve. Imagine a perfectly smooth, frozen lake where nothing ever moves or changes. Without change, without a sequence of events, time essentially has no meaning. The hyper-accelerated expansion of cosmic inflation was the ultimate catalyst for change. It shattered the perfect, microscopic stillness of the early quantum state, tearing particles apart and creating the vast, complex, evolving universe we see today. In a very real sense, the violent decay of the false vacuum may have been the very event that set the cosmic clock in motion. As the inflaton field collapsed and dumped its colossal energy into the universe, creating the fiery plasma of the Big Bang, it established the arrow of time that governs our lives today. This directionality is driven by a fundamental principle of physics called entropy, which is a measure of disorder or chaos in a system. The universe began in a state of incredibly low entropy, a state of extreme order, despite its searing heat. Ever since that ancient moment, 13,800,000,000 years ago, the universe has been expanding, cooling, and gradually moving toward a state of higher entropy or greater disorder. The relentless forward march of time that we experience, the reason we remember the past, but not the future, is intimately tied to this universal increase in entropy. Every tick of your watch, every beat of your heart is a tiny echo of the universe slowly winding down from the initial, highly ordered state created by the incredible power of cosmic inflation. As we look out into the deep silence of the cosmos using powerful telescopes designed by the National Aeronautics and Space Administration and the European Space Agency, we are not just looking across vast oceans of space, we are looking back across immense gulfs of time. Because light travels at a finite speed of 186,000 miles per second, the images of distant galaxies we capture are essentially ghosts, snapshots of the universe as it was billions of years ago. When we observe the cosmic microwave background, we are seeing the ancient light of the universe when it was just 380,000 years old. The universe is a gigantic, living time machine. But the expansion of space adds another layer of profound complexity. As space stretches, it also stretches the light traveling through it. This cosmic expansion makes time itself appear to run slower for incredibly distant objects relative to us. We are separated from the edges of the universe not just by billions of light years of distance, but by the fundamental bending of time across the expanding void. It is completely natural to feel a sense of overwhelming smallness when confronted with the infinite scale of cosmic time. A human life, spanning perhaps 80 or 90 years, is barely a fleeting spark in the dark compared to the 13,800,000,000 year history of the universe. To count the age of the universe in seconds would require thousands of generations of human lives. The stars we see in the night sky will burn for millions or billions of years. The quiet, invisible black holes that anchor the centers of galaxies will endure for unimaginable eons, slowly evaporating over timescales that require numbers with dozens of zeros just to write down. Against this backdrop of deep, ancient time, our daily worries, our hurried schedules, and our transient anxieties can suddenly seem very insignificant. But this realization does not have to be a source of despair. Instead, it can be a source of profound, liberating peace. It is a gentle reminder to let go of our need for control and simply exist in the present moment. We are not separate from this grand, unfolding timeline. We are an intimate part of it. The carbon, nitrogen, and oxygen atoms in our bodies were forged in the cores of stars that lived and died over billions of years. We are the temporary, conscious custodians of ancient, recycled matter. The fact that the universe took nearly 14 billion years of patient, quiet expansion, star formation, and planetary evolution just to create a mind capable of asking these profound questions is a beautiful, staggering miracle. Our consciousness is the universe experiencing its own flow of time. When we pause in our busy lives to gaze up at the vastness of the night sky, we are actively participating in the cosmic story. We are the universe, remembering its own fiery birth, marveling at the strange quantum rules that govern its expansion, and looking forward into the infinite mystery of its future. We are the cosmos, waking up to feel the warmth of the sun and the passage of the years. The journey to understand what cosmic inflation is made of has shown us that the universe is a dynamic, interconnected masterpiece of energy, probability, and stretching spacetime. We have seen how the microscopic jitters of the quantum vacuum were magnified to create the largest structures in reality, and how the decay of the inflaton field set the very arrow of time into motion. But as the universe continues to expand, driven by the mysterious, relentless push of dark energy, what will happen to this intricate web of galaxies, stars, and time itself? In the next part of our shared exploration, we will journey into the deep, quiet future of the cosmos. We will look at the ultimate fate of the universe and discover how the principles of quantum mechanics might shape the final, silent chapters of existence. Let the ancient rhythm of the expanding cosmos bring you comfort. Rest deeply in the knowledge that you are a beautiful, brief, and essential note in the infinite symphony of time. Have you ever stopped to observe the ocean at night, listening to the constant sound of the waves crashing against the sand, and felt the vastness of time stretching out before you? There is something deeply peaceful and at the same time melancholic in the way the water moves, an infinite tide that seems to care nothing for our daily worries. When we look up at the stars, we often imagine that they will be there forever, shining constantly on the grand cosmic stage. We are used to the idea of a vibrant universe, full of light, heat, and movement. But the story of cosmic inflation and quantum physics teaches us that the universe has a beginning, a middle, and, in a fascinating and silent way, a final destiny. To fully comprehend what cosmic inflation built, we must travel into the deep future, far beyond the life of any star, and explore how the dance of energy and expansion will finally resolve itself in the dark. The universe will not end with a massive explosion, but with a gentle, infinite sigh. Before we dive into the distant and silent future of our wonderful cosmos, I would like to gently pause our path. Hello again, my dear traveler. I am Walter, the explorer, and it is a profound privilege to share this contemplative journey through space and time with you. As we navigate these ancient and future cosmic seas, I noticed something that caught my attention. 73% of the wonderful people who watch these meditative explorations have not subscribed to our channel yet. If you are finding a moment of peace, a sense of intellectual safety, and a deep wonder in our shared stories, please consider taking a brief moment to subscribe. It immensely helps our community of curious minds grow and shows me that you wish to continue unraveling the beautiful secrets of the universe by my side. I sincerely thank you for your kindness, your patience, and your constant company. Now, let us return to the infinite expansion and discover how the tapestry of the stars will one day begin to fade away. Remember dark energy, that mysterious and relentless force that is currently accelerating the expansion of the fabric of space. This dark energy acts as a ghostly echo of the original cosmic inflation. During the very first and briefest moment of creation, the inflaton field pushed space apart at speeds incredibly faster than light, driven by an unstable state of false vacuum. Today, dark energy seems to be doing something frighteningly similar, although at a much slower, gentler, and more gradual pace. As space expands, the gravity that pulls galaxies toward each other becomes increasingly weaker over larger astronomical distances. At this very moment, while you breathe calmly and our planet spins, the distance between our galaxy and the most distant galaxies is growing. If this acceleration continues the way astrophysicists predict, the universe will enter a long, slow, and isolated phase known as the Big Freeze. Try to imagine what the night sky will look like 100 billion years from now. Today, we can observe billions of galaxies with our powerful telescopes, creating a brilliant, interconnected cosmic web. But in the deep future, the expansion of space will carry these galaxies so far away from each other that their light will no longer be able to cross the ever growing vastness. The edge of the observable universe will shrink from our point of view. Slowly, one by one, distant galaxies will disappear behind the cosmic horizon, dragged away by the invisible tide of dark energy. To any civilization that might exist in the distant future, the universe will appear incredibly empty and dark. They will look out from their home galaxy and see only an absolute black abyss, without any evidence of the glorious past when galaxies formed massive, shining swarms of light. They might mistakenly think that they are completely alone in the immensity of nothingness. This gradual isolation should not bring us fear, but rather a profound sense of gratitude for the exact moment in which we exist. We are incredibly fortunate to live in what cosmologists call the stelliferous era, a brief period of flowering where the universe is rich in stars, heat, and visible structures. The primordial energy that the inflationary field released into the universe through the creation of the searing plasma was carefully shaped by gravity to create perfect homes for life. But usable energy is finite. Stars are powerful nuclear furnaces, but their fuels will one day run out, trillions upon trillions of years from now. The very last of the small, faint red dwarf stars will eventually burn through their final supply of hydrogen. They will not explode in glory, but will simply fade away quietly, transforming into dark, cold embers drifting through an endless black ocean. When the last star dies, the era of light will reach its peaceful end. But the universe will not be dead yet. It will become the domain of much stranger entities, formed from the extremes of physics and intense gravity. The cosmos will consist of gigantic black holes, dead neutron stars, and scattered particles wandering alone through the boundless vacuum. This is where quantum physics returns to take the leading role, connecting the mysterious properties of the vacuum with the fate of everything we know. Black holes, the absolute prisons of light and matter, are not eternal. The great physicist Stephen Hawking revealed that due to quantum fluctuations at the event horizon of a black hole, these fallen stars are not completely black. They slowly, on timescales that break human minds with their trillions of years, leak quantum radiation, shrinking gently and almost imperceptibly back into nothingness. Imagine this meditative and terrifyingly beautiful process. The universe, which was born from the violent and sudden decay of the inflationary field, will eventually see its largest and most massive structures dissolve back into pure quantum energy. As a black hole evaporates, it returns its stolen mass back to space in the form of photons and virtual particles. It is a gloriously slow and silent fading. When the last black hole evaporates, which will take a number of years, followed by tens of thousands of zeros, the universe will reach the ultimate dark ages. There will be no structures. There will be no planets. There will be no light except for individual photons traveling eternally without ever hitting anything. And time might also completely lose its meaning, because in a universe without events, where no significant physical change occurs, past, present, and future become completely identical. This immense stillness that awaits us raises an essential question about the very nature of nothingness. At the beginning of this grand stage, we argued that the vacuum is never truly empty according to the fundamental laws of quantum mechanics. If the seeds that built all the galaxies came from tiny quantum fluctuations spread by an unimaginably rapid expansion, what will happen to the vacuum at the end of all things? The inflaton field decayed from its false vacuum state to give us the fiery reality we know, creating all the energy and tangible matter. However, what if the current space, which seems serene to us, still harbors an underlying level of invisible tension? Some theories suggest that our current cosmic state might still be in a subtly unstable state. If this is true, after countless cosmic eons, the quantum fluctuations themselves could, in theory, originate new transitions that would redraw all the constants and all the natures of the current cosmos, creating another false vacuum where another universe would bloom. This expansive notion brings the wonderful idea of the multiverse to the forefront, redefining our final journey. Perhaps this dear universe of ours, with all its intricate stellar formations, vast and solitary cosmic clouds, and wonderful thinking minds, is simply a single, long, and majestic breathing cycle of inhalation and exhalation that endures for all time. We are, as Carl Sagan so perfectly said, wonderful way for the universe to know itself. We are therefore rare and precious expressions formed by the decay of the initial field, witnessing the rising and the ephemeral, magnificent shining of the stars, and also foreseeing the immense, peaceful hours that, in absolute silence, will welcome the lights of the past that travel until they are lost in the eternally expanding and unbounded frontiers. Sound will not propagate in the depths, and light will eventually not be able to crash against any material barrier. It is like returning to the beginning in total peace, connecting the quantum energy at the moment of the great inflation to the freezing, dark, and deeply calm silence that will shelter tomorrow is more than just the mathematical pursuit of astrophysical magnitudes. It is a profoundly moving philosophical way to recognize the immense value of the singular moment we occupy as the thinking explorers of this infinitely and constantly expanding journey. You, me, the comets that fly distantly through the eternal ice, the monumental mountains on moons that orbit gas giants sweeping up cosmic dust. We are all the shining pieces of this temporary drama embedded and set between two long, unimaginably beautiful and colossal silences. It is in the exact understanding of these incredible scientific facts where we find sublime rest. Learning astronomy helps calm the small earthly conflicts of our days. It gently and quietly transforms us into beings infinitely respectful toward what we completely do not know and amazed by the few laws that we finally come to know and learn with irrefutable patience. In our next and admirable part of the shared universal story, we will navigate together to review everything we understand about the relationship of the quantum, macrocosm, and microcosm with the grand theories of total interconnection of space and time and sensitive minds. We will explore the beautiful, implicit connection and the boundaries that invite the infinite pursuit of existential scientific curiosity without fear of the dark. The journey in pursuit of the mystery is the essence of the spirit and eternal wonder. In a silent, peaceful, and majestic environment, of revelations that proceeds at the speed you might desire, and without ever losing the tender dazzle that enriches your inner peace in rest. Appreciate the expansion, immerse yourself in your serene cosmic contemplation, in the wonderful certainty that it is all a single, gigantic, and wonderful unity of boundless knowledge. Have you ever closed your eyes in a perfectly quiet room and tried to imagine the absolute edge of everything? Where does the universe end? And what exists beyond the boundaries of our comprehension? When we embark on a journey through the fundamental nature of reality, exploring the bizarre and beautiful world of quantum physics and the staggering, hyper accelerated expansion of cosmic inflation, we inevitably arrive at the limits of human imagination. We have traveled together from the deepest, darkest voids of the future all the way back to the incredibly hot, dense, microscopic seed of the primordial cosmos. We have seen how the solid reality we interact with every single day is merely an illusion, a magnificent structure built upon the foundation of fuzzy probabilities and fluctuating quantum fields. The sheer scale of what we have uncovered is enough to make anyone feel a profound sense of intellectual vertigo. But the fact that your mind, a delicate network of neurons housed within a fragile, temporary body, can hold the concept of an infinite, expanding universe is perhaps the most glorious mystery of all. Before we bring this immense, shared contemplation to a gentle close, I want to pause and thank you for your incredible presence. Hello, my wonderful friend. I am Walter, the explorer, and it has been an absolute honor to be your guide through the silent, ancient mysteries of the cosmos. As we reach the culmination of this particular voyage, I have noticed that 73% of the wonderful people who watch these meditative stories have not subscribed to our channel yet. If you have found a quiet sanctuary here, a place of peace, intellectual safety, and deep wonder, please consider taking a moment to subscribe. It truly helps our small community of stargazers grow, and it lets me know that you want to keep walking this infinite path of discovery by my side. Thank you for your warmth, your boundless curiosity, and your beautiful mind. Now, let us gather all the fragmented pieces of our quantum puzzle and see the magnificent, unified picture they create. The question of what cosmic inflation is made of has led us down a path that fundamentally alters our relationship with existence. We began by asking how the immense, dark voids between the galaxies are expanding, and we found our answer not in the massive scale of the cosmos, but in the incomprehensibly small realm of subatomic particles. We learned that a perfect, empty vacuum is physically impossible according to the strict, elegant rules of quantum mechanics. Instead, empty space is a boiling, vibrating ocean of virtual particles constantly popping into and out of existence, borrowing a tiny fraction of energy from the silent void and returning it almost instantly. During the very first fraction of a second of time, roughly 13,800,000,000 years ago, this bubbling quantum ocean was trapped in an unstable, high energy state known as the false vacuum. The intrinsic, repulsive energy of this inflaton field acted as the ultimate engine of creation, pushing the fabric of space-time apart at a speed that vastly exceeded the speed of light. During this brief, violent epoch of exponential expansion, the gentle, microscopic jitters of the quantum vacuum were caught and frozen. They were stretched across the expanding void, transformed from ephemeral, invisible probabilities into macroscopic, permanent realities. The vast, majestic tapestry of the night sky, with its 100 trillion stars in giant galaxies and its endless, dark stretches of empty space, is nothing more than a magnified, frozen photograph of quantum uncertainty from the very dawn of time. Every single structure we observe through the incredible mirrors of our modern space, telescopes, or the ancient data gathered by missions designed by the National Aeronautics and Space Administration, traces its ultimate lineage back to those primordial quantum ripples. Gravity, acting with infinite patience over hundreds of millions of years, simply pulled the slightly denser regions together, igniting the first stars and weaving the intricate, glowing cosmic web that illuminates the dark today. This realization is not just a triumph of modern astrophysics, it is a profound, deeply personal truth that connects you directly to the very origin of everything. The heavy elements in your blood, the calcium in your bones, and the complex molecules that allow your brain to process these very words were forged in the fiery hearts of ancient, dying stars. But those stars themselves were born from the gentle, gravitational collapse of hydrogen gas that gathered exactly where a microscopic quantum fluctuation told it to gather during the hyper-accelerated expansion of cosmic inflation. You are a direct, unbroken continuation of the Big Bang. You are made of the exact same stardust and quantum probability as the most distant quasar burning at the edge of the observable universe. We are not separate from the cosmos, watching it from the outside. We are the cosmos. We are the universe experiencing itself, seeking to understand its own magnificent quantum origins. As we contemplate the staggering complexity of the inflaton field, the bizarre connections of quantum entanglement, and the slow, inevitable march of time driven by the increase of entropy, it is entirely natural to feel a sense of overwhelming smallness. The universe operates on scales of distance and time that require numbers with dozens of zeros just to write down. The great physicist Max Planck once observed that science cannot solve the ultimate mystery of nature because we ourselves are part of the mystery we are trying to solve. But rather than feeling intimidated by this infinite unknown, we should feel a profound, liberating sense of peace. The universe does not demand that we understand every single mathematical equation. It only invites us to look up, to ask questions, and to feel the gentle awe that comes from recognizing our place within the grand design. The beauty of scientific discovery is that it is never truly finished. Every answer we find uncovers a dozen new mysteries waiting to be explored. When we mapped the cosmic microwave background and found proof of cosmic inflation, we immediately stumbled upon the profound mysteries of dark matter and dark energy. The tension between what we currently know and the vast oceans of what remains undiscovered is the very engine of human progress. It is a gentle, eternal journey that does not require us to rush, but only to observe and to wonder. We are participating in a tradition of inquiry that stretches back to the first humans who looked up at the night sky and felt a connection to the twinkling lights above. The knowledge we have gathered is a shared heritage, a testament to the incredible power of cooperative curiosity that unites us as a single species, adrift on a tiny, fragile planet wandering through the silent immensity of space. As you move forward in your daily life, carry this profound cosmic perspective with you. When the temporary anxieties of the modern world threaten to overwhelm your peace of mind, remember the vast, silent patience of the ancient universe. Remember that the space around you is not empty, but filled with the vibrating energy of the quantum fields that birthed reality. Remember that the light from the most distant galaxies has traveled for billions of years just to gently touch your eyes. You are a localized, conscious expression of a universe that is incredibly old, vast, and unimaginably beautiful. Let the scale of the cosmos be a source of intellectual safety and deep comfort. The mysterious forces that push the galaxies apart and govern the chaotic dance of subatomic particles are the exact same forces that hold you gently to the earth. Allow this ancient rhythm to soothe your worries and calm your spirit. Our shared exploration of what cosmic inflation is made of has reached its quiet conclusion. But the journey of discovery is an endless road. There are infinite mysteries still waiting in the dark, countless wonders quietly orbiting distant suns, and elegant, hidden rules of physics waiting to be uncovered by the curious minds of tomorrow. The universe is a generous host, always ready to reveal a new layer of its staggering beauty to anyone who is willing to listen to the silence and look deeply into the void. I hope our shared time has brought you a sense of tranquility, a renewed appreciation for the wonderful nature of reality, and a deep, lasting connection to the grand cosmic dance. Rest now, my friend. Let the ancient stardust in your veins settle and drift peacefully in the knowledge that you are an essential part of the infinite mystery. Until our paths cross again in the quiet expanse of the night, find peace in the beautiful unknown.